This video we have started the graphs 4, and you can see the page number 259 in your textbook. The name of the chapter is graphs 4, and this is only the introduction part of the graphs 4. Here we will discuss some subtopics that are in this chapter, like we have quadratic curves, we have quadratic equations, quadratic curve number 1. Number second, we have quadratic equation in this chapter. So we can see here the quadratic curve and the quadratic equation. Before this, I will give you the brief introduction of the linear curve. You might have seen y is equal to mx plus c. This is a curve of straight line. This is a curve of straight line. That is, if we have a curve in this form like y is equal to 2x plus 3. If I will draw a graph of this equation, or I can see of this curve, you can see the graph will be a straight line. And this 2, that means this m, is the gradient. That means measure of slope. And here this c is the y-intercept in this. So you can see from here y is equal to mx plus c. This is the curve of straight line, and its gradient is here m. That means m, the coefficient of x. Here the coefficient of x is 2, so that the gradient is 2. Here the c, value of c is 3. It means the y-intercept is 3. You know what is y-intercept. For example, we have a graph. In every graph, this is origin, this is x-axis, and this is y-axis. For example, the graph is like this. You can see this is the point where the graph touches the y-axis. This point is called y-intercept. So what is the y-intercept? Y-intercept is that that point where the graph touches y-axis, and this is called the x-intercept. So x-intercept is that point where the graph touches x-axis. So you can see here y-intercept, x-intercept. If you have the equation, if you have the curve y equals to mx plus c, so what you will think, this m is what? This is the gradient, and this c is y-intercept. What is gradient? It is actually the measure of slope. Measure of slope. In graph 1, you have calculated the measure of slope, that is y2 minus y1 divided by x2 minus x1. You can see when y is equal to mx plus c, this is linear curve. You can see the degree of variable, that's x, it is 1. So highest power of the variable in this curve is 1. That's why it is called a linear. Now we have another one, y is equal to ax square plus bx plus c. This is another curve. You can see the power of the variable. Highest power of the variable is 2. That means once the power of the variable is 2, it's quadratic. It's quadratic curve. You can see if I have the expression x plus 1. From this expression, the power of variable is 1. I can see this is linear expression. And if I have x square plus 1 or x square plus 2x plus 1, you can see the highest power. Highest power of the variable in these two expressions is 2. That means it is quadratic expression. What is it? Quadratic expression. When we are calculating the highest power of variable in any expression, that is called the degree of that expression. What? Degree of that expression. So I can see here the degree of this expression is 1. That's why it's called the linear curve. Here the degree of this expression is 2. That's why it's called the quadratic curve. And one more thing is there. For example, if we have x square ax square plus by plus cz is equal to y, like this, if we have a expression like this is not the quadratic curve. This is not the quadratic curve. Why this is not the quadratic curve? The general form, the standard form is like this. That means every quadratic curve should be in this form. That means if we have here the x variable, here should be the x. If we have here the y variable, here should be the y. And a, b, c are simply the constants. That constant means the numbers. Sometimes a is 1, -1, 2, 3, 0, like that. Any real number it can be. C is here also the constant. So what exactly is I mean to say here, if we have a y square plus by plus c, then yes, this is the quadratic expression. This is the quadratic expression. Here the variable is y. You can see here y square and y is there. This is not, if it is like this, x, y, z, different variables are there and it's not written in order, this is not the general form. So you should remember always the quadratic curve will be in this form irrespective of the variable. Here it can be az square sometimes plus bz plus c. So you can compare these. You can see here the same variable, it's z. In place of x it is z, in place of x it is z, and here the degree, that's highest power of variable, is 2. These a, b, c are the constants, remember this thing, or the constants. And next thing we need to understand about this is, if we have y is equal to ax square plus bx plus c, you can see this a is called the coefficient of x square. This b is called the coefficient of x, and c is the constant term. Understand here, a is the coefficient of x square, b is the coefficient of x, and c is the constant term. If I have an example like y is equal to 2x square plus 3x plus 4, you can see here what is the value of a, that's 2. What is the value of b, that is 3. What is the value of c, that is 4. So here the coefficient of x square is 2, here the coefficient of x is 3, here the constant term is 4. And one more point, you can see this c is, once we are plotting the graph of this curve, this c is always the y-intercept. That means c is that point which cuts the graph at y-axis, or we can say the graph, the c is that number, that point which is on the y-axis, and the graph is passing through that point. That's why it's called the y-intercept. So this is about the quadratic curve. Understand is what is quadratic curve. Y is equal to ax square plus bx plus c. One more example I will give you. If I have y is equal to x square minus 2x minus 1. What is the value of a here? You can see the coefficient of x square. Coefficient means a numerical value is 1. So a is 1. The coefficient of x here, it's minus 2. The constant term here is minus 1. So from this expression I can write a is equal to 1, b is equal to minus 2, c is equal to minus 1. So if I will ask you what is here the y-intercept, it's 4. What is here the y-intercept? It's minus 1. Now next we see what does graph of the quadratic curve looks like. We know y is equal to mx plus c. Graph of this curve is a straight line. It is a straight line. And we have next curve, this is quadratic curve ax square plus bx plus c. What is the graph of this? You can see when we are plotting the graph of this curve, it will be U-shaped like this, and this shape is called a parabola. And sometimes it will be inverted U-shape like this. Sometimes it will be like this, sometimes it will be like this. These are called inverted U shapes or inverted parabola. Now you can see when it is U shaped, that's parabola, and when it is inverted parabola. If the value of a, that means coefficient of x square, is greater than 1, sorry, greater than 0, then its shape will be parabola, U shaped. If its value is less than 1, that's coefficient of x square is less than 1, it means its graph will be inverted. That's like this inverted parabola. Got it? The shape, the curve of this quadratic curve is a parabola. This U shaped is known as the parabola. And here we have this inverted U. This inverted U, you can see when a is greater than 0, when a is less than 0, we will check if I have the curve like y is equal to 2x square plus x plus 1, and one curve y is equal to minus 3x square plus 4x plus 5. You can see here the value of a is minus 3, that is the value of a is less than 1. You can see here the value of a is greater than 0. Here it's less than 0, here it is greater than 0. So I can say the graph of this will be the parabola and the graph of this curve will be the inverted parabola. This was about this. Now you can see from the graphs, if we have a graph like this, we have graph like this, it is 0, it's 1, it's 2, it's 3, it's 4, it's 5. This is x-axis, it's 1, 2, 3, 4, and it's 5. This is y-axis. For example, we have a graph, we have plotted a graph of any quadratic curve, and graph is looking like this. And you can see from the graph what is y-intercept. Y-intercept is 5. What is x-intercept? X-intercept. There are two x-intercepts. One is 2. Here you can see where the graph passes the x-axis. That's 2. And one more is, that is 5. So we have two intercepts, x-intercepts, 2 and 5. And here we have 5, that's y-intercept. Now you can understand this y-intercept, this is x-intercept. This is about the graphs. And sometimes we have the graph like this. That means only one point, there will be only one x-intercept. And sometimes we will have like this graph. That means there is only here in the real, there is y-intercept and there is no real. Real means the value like 1, 2, 3, 4, minus 1, minus 2, whatever the numbers are, whatever numbers, there are no real x-intercepts. Sometimes when we will see the graph of the quadratic curves, we will have like these type. Understand this, there are two y, sometimes there are two y intercepts. Sometimes there are only one x-intercepts, sorry, two x-intercepts. Sometimes we have only one x-intercept. Sometimes we will have no real x-intercepts. For example, the graph is like this, it's going above the x-axis. You can see there is no real number like 1, 2, 3, 4, etc., etc. This all was about the quadratic curve. Now we will see the quadratic equation. What is quadratic equation? You can see here we are writing the simple equation like y is equal to mx plus c. If I will write mx plus c is equal to 0, this will become the equation. Since this is a linear curve, this is now linear equation. Here the degree of the expression, degree of the equation, degree of the expression is 1. That's the highest power of the variable. Similarly, if I have the curve, quadratic curve ax square plus bx plus c, so I can write it ax square plus bx plus c is equal to 0. This is the quadratic curve and this is now the quadratic equation. Understand this. How to write the quadratic curve, how to write the quadratic equation, how you will understand. When we are writing the equality, when we are equating this expression to 0, what does that mean? That means we are writing equal to 0. It becomes the quadratic equation. So the general form of the quadratic equation is this. This is general or standard form of the quadratic curve. This is standard or general form of quadratic equation. I will write here general or standard form of quadratic equation. Now you can see here ax square. A is the coefficient of x square, b is the coefficient of x, and c is here the constant term, equal to 0. Why we are equating it 0? This is the general form. In the general form we have to do that. We have to do that. It means the equation in this format, in this form, is the quadratic equation. I will say you, here is one special case. If a is equal to 0, for example, we are writing 0 x square plus 2x plus 1 equal to 0. What is this equation? It is 0, it is 2x plus 1 equal to 0. It remains the linear equation. Why? Because x square is not the present. When x square is not present, it is not quadratic equation. So we should write a should not be equal to 0, and also in the quadratic curve a should not be equal to 0. A should not be equal to 0 because its degree will vanish, its degree will decrease by 1, so it will not be the quadratic equation. Now here you should understand what I am saying. Ax square plus bx plus c is equal to 0. This is the general and standard form of the quadratic equation. Now we will give some examples on the quadratic equation. If I have x square plus 1 minus x square plus 14x minus 1 equal to 0, 2x square plus 1 equal to 0, 3x square minus 2x minus 1 equal to 0, and one more we have 4y square plus 2y minus 1 equal to 0, 6z square plus 3y plus 2 is equal to 0, and we have 6c square or 6p square plus 2p plus 1 equal to 0. Now check this. You can see this is x square plus a is here 1, b is here 14. A is the coefficient of x square, b is the coefficient, this 1 is the coefficient of x square, and 14 is the coefficient of x, and c is here minus 1. Yes, this is the quadratic equation. Here a is here 2, the coefficient of x square is 2, and bx is not present, so b is the 0, b can be 0, and c is 1. Yes, this is the quadratic equation. Here a is 3, and b is minus 2, c is minus 1. This is the quadratic equation, and highest degree is. Here a is 4, only the variable is here y. This, yes, this is the quadratic equation, because in place of x we can put y, we can put any value, any variable. 4y square plus 2y minus 1 is equal to 0. A is here 4, the coefficient of y square, and b is here 2, c is minus 1. Yes, here 6z square plus 3y, you can see here it is z, okay, it is y, so it is not in that form. We should have the same variable. This is not the quadratic equation. Here 6p square plus 2p plus 1, yes, this is the quadratic equation, because you can see in place of x square we have p square, in place of x we have p, and the value of a is the coefficient of p square, that is 6, and the value of b, that is 2, and the c, that is 1. So these are the few examples of the quadratic equations. Now we will move to the solutions of the equations. You can see here I wrote solutions of the equations, quadratic equations. What is actually the solution? We will try to understand what is this solution. For example, we are writing solve for this equation. The solutions of quadratic equation are also called the roots of quadratic equation. Roots of quadratic equation. We will try to understand what is this solution first. If I am writing the linear equation x plus 1 equal to 0, tell me the value of x so that LHS will become equal to RHS. See, what is LHS? This portion is left hand side, this portion is right hand side in equation. Okay, what is the value of x so that LHS becomes equal to RHS. That's x plus 1. If I will put in place of x minus 1 plus 1, it will become 0. So I can say when x is equal to minus 1, at that point in the equation LHS becomes equal to RHS. That means equation gets satisfied. So what it does mean, when the value of x is minus 1, so at that time LHS becomes equal to RHS, equation gets satisfied. So I can say x is equal to minus 1. That's x is equal to minus 1 is the solution of equation. So what we can say now, what is the solution of the equation? It means on substituting the value of the variables in a given equation, if the equation gets satisfied, that's LHS becomes equal to RHS, that is the solution of the equation. If I have one more equation here, x plus 1, x minus 1 equal to 0. If I will put x is equal to 1 plus 1 minus 1, it will become equal to 0. So I can say x is equal to 1 is the solution of the this equation. You got that? The solution, what is actually the solution? It is the value of the variable that satisfies the equation. That's called the solution of the equation. You might have gone through the algebra. We have solve for x, like we have x 2x is equal to 10. That is x is equal to, we are transposing this 10 divided by 2, 2 ones are 2 5s are, so x is equal to 5. So what is this actually? X is equal to 5 is the solution of the given equation. That means when we are putting x is equal to 5 here, we are getting the solution, we are getting left hand side equals to right hand side. The equation gets satisfied, and this is the solution of the equation. So I hope you got my point, what is the solution of equation. And remember one thing, a linear equation has only one solution, while as the quadratic equation has two solutions. Quadratic equation has, first point, quadratic equation has two solutions. That is, x will have one value and second value. Now x-intercepts of curve y is equal to ax square plus bx plus c are solutions of quadratic equation. What does that mean? If we have a graph here, we have this parabola, you can see here are two intercepts, let it be 1, it be 3. What are x-intercepts here? 1 and 3. When 1 and 3 are the x-intercepts, we can say x is equal to 1 and x is equal to 3. These are the solutions of that equation. For example, if we have the graph like this, the parabola is cutting only at single point in x-axis. So it means, for example, it is 2. So we have to write this 2 times. That means x is equal to 2, x is equal to 2. There are two solutions, but they are same and equal. So remember always, a quadratic equation has the two solutions. If the parabola is cutting at one point in x-axis, that means the value is repeated. We have to write 2 times that value. The same value is the solution of the quadratic equation, and it is what it has to be written 2 times here. So this is about the solution of this quadratic equation. One more, if we have like this, if a quadratic equation is the graph of the curve is like this, you can see this parabola does not intersect the x-axis. This is x-axis, this is y-axis. So in this case, what we will say? We will say there are no real solutions. No real solution. Solutions are there, but real solutions are not there. You have to remember, it will have the imaginary solutions. The topic is not here. We should not discuss that topic here, but you have to remember only one thing: no real solutions. What does that mean? We have the real numbers. All the numbers we can write, like root 2, root 3, 1, 2, 3, 4, minus 1, minus 2, all fractions. These are the real numbers. You can see that this curve will not have the x-intercepts as the real. real intercepts, and the equation will have no real solutions because this graph is not intersecting here the x-axis. So remember one thing, there are three cases, this one case, this case, and this case. You can see from here, and y should be always there. Y should be always there. For example, if y is equal to 0, then the graph will pass through the origin. If y is equal to 0, graph will pass through the origin. If y is equal to 0, graph will pass through the origin. One more important point I want to discuss here, that's, for example, if we are drawing the graph for the linear equation, we are drawing the straight line like this, and sometimes we are drawing the graph generally like this, straight lines. But in quadratic curves, always remember it should be a curve like this. We should not draw the straight lines like this. Never connect the points with the straight lines. It should be like curves. Only this point you should understand.